I'm going to talk about how to refactor, how to test, and how to make hard-to-test code easy to test code. Before I get to that, I want to say us to think about and thank the people without which we would not be here. Because it takes tremendous effort to actually run a conference. So I would want us to give a big hand for all the organizers, all the volunteers, the hotel staff, the conference staff, the people who makes it possible for us to be here. So big hands for. So I'm Aki Salmi, I'm coming from Finland, and I love T-Turtle t-shirts. I think that's the most important thing to know. In this talk, you're going to be seeing code in there. I'm going to make some visuals. So I'm trying to make it visual in different ways. So not just code. There's different ways of doing it visuals. There's colors, there's shapes. Focus on that. Don't try to read the code. It's going to be small when you start seeing it. And that's also how I sort of think about coding myself. Shapes. The example that I'm going to show to you is based on a code exercise on GitHub. Why do I do things like code exercises on GitHub and take it from here is that this code looks real. But it's simple enough so that we can practice. I do a lot of practice in coding. I teach people into coding very tiny practices, very focused practices. And this is to learn the basic skills safely that we can then take into production. So all the skills that I'm sharing here today with you are things that I use in production often. And these are skills that we can all learn, like in safe, contained spaces. So this is the code that we need to work with, and it's a code that it's an HTTP REST API. It's a get request on get the prices of lift passes, and it needs to be changed. So there's a changing requirements. It's not testable. Well, it is, but it would require us to have a Docker instance and a running database there, and we would need to fill database in there. Makes it a bit tricky in there. And domain concepts are hidden in the code. I'm pretty sure there is a bug, like a domain bug in this code. You're going to see that later. I don't see it when reading it. And the important here is when I talk about legacy code, I say that's the code that provides value. That's the reason we get paid. It's legacy for a reason. It serves the purpose every single day. So this is the code when I see code looking like this, and it can span in like many files and stuff, and if I need to go and make modifications, I might do this in a way that I don't want to read the code. I don't want to understand what it does. And I can show you that I can actually refactor this without reading the code at all, without understanding what's happening in there. These are tricks that we can learn. This is just, as I said, thinking about shapes and colors. So the colors sort of have here a meaning. So I just the colors here is the blue one is database operations, orange is HTTP REST API operations, and green ones is domain. So this is just shows how scattered and messed up the code is. And with just like few refactorings that I'm showing to you, we can get the code look like this, where it just takes the HTTP, creates like domain concepts, calls domain logic, and then sends data back to the through the REST API. So we go from the one on the left, which is a bit sort of thing, and remember the one on the left serves its purpose. That is something that provides value every single day. I don't say this is bad. I say this provides value every day. And this is what we can turn it up into so that we can extend it. We can create more and new features in there. And the one on the right, you see that looks a bit like hexagonal or ports and adapters architecture. And there we come with the dilemma. So the legacy code dilemma by Michael Feather saying when we have to change code, we should have tests in place. To put tests in place, we often have to change code. Has anyone ever experienced this, that you want to refactor, but there's no tests? But to add tests, you need to refactor? Fun, right? I have 2 tricks to change any hard-to-test code into easy-to-test code. Every single one. I haven't seen a code that I cannot test or make it testable. I'm showing one of those things here today to you. So what sort of makes my thinking, what makes code hard to test, or unit test in this case, it's everything that, if we think about unit as a box, everything that goes above the box, like outside the box to get data or to things, that is what I consider makes things more difficult to test. And in this case, the example that I'm sharing is the first one, the second one, and the 2 last parts. Those are all in this example code. So this is pretty good code by Johan Martinsson. So it's a very good exercise, actually. So are we ready? Cool. So we're going to go through 3 phases: take a mess, make a mess, and fix the mess. That's actually what whenever working with legacy code, this is actually something that I do. I make huge messes when I'm coding, but it's okay. It's a promise that I will actually clean it later. Don't be afraid of making a mess. Just clean it later, like soon. Turning hard-to-test code to easy-to-test code is surprisingly easy when we know how to do it. Adding unit tests into easily testable code is easy. There's a talk by Sandy Metz. Unfortunately, I don't have that in the slides, but there's a talk by Sandy Metz called Magic Tricks of Testing. Magic Tricks of Testing, which is the perfect talk for how to test, how to unit test anything, like perfect. 26 minutes in Ruby, really worth watching. And then the last one, what we do is how to refactor domain concepts into existence. So the code looks like this. So there's some hard-to-test code. There's some hard-to-test code entangled within the domain code. And then there's a bit of unfortunate abstraction, and there's some important abstractions. Bit more concretely, connections to DB in the routes. Like we're in the HTTP layer, right? Data coming in HTTP, and we do some SQL scripts in there. And we want to fix this. So the first thing that we do is make this easier to test. So this is one of the tricky parts. In the very beginning of HTTP routes, we see this is a request coming in, and we go to a connection. The connection is a global variable that actually makes a database connection. So this is actually a database connection. And then we do a bit of magic in there. So we make this. This is sort of something that makes it difficult to unit test, because to run this, I actually, even though if I could extract the async function into a function and call that, and I can test request responses easily, annoyingly, but easy, but then I would need to have the database. Very annoying. So what we sort of want to do in this case, the first thing, and this is the first trick that I'm telling you, start making space. Press enter. A lot. That helps. Then what we do is we wrap the function, the database function, that actually makes the database into another function, and then we call it. We haven't changed anything, right? We can write this by hand, but I have a tool that does this for me, so I don't need to write anything. I don't need to touch code at this point. So I have tools. I have better tools than ChatGPT that does this. It's IDE. So I haven't changed anything. But I've made the first step. I just made a bigger mess. I just took a mess and I made a bigger mess. I just added a function and I called the function. I just add code, right? And then I just sort of internally move the call to the wrapper function into the domain logic. It's sort of small change. So how that is done specifically in this case is that we take the connection query, we create a function, and we give it a meaningful name. You know that naming is important. This is my way of naming, honestly. If I don't know what it is, I name it something. Because that's a promise from me that I will actually, when I figure out what this is, I will change it. This is a promise for myself. Then I just copy-paste the code a bit and call the get something. This is something that I can write myself safely, but without tests. No, I would not want to do that. But if everything like this happens automatically with my IDE, I'm okay. I don't need tests to make this refactoring if I'm using my IDE for it. And the next thing is just like extracting a parameter, because this get something is not really useful right now. So just to extract the parameter, so we basically take the parameter, we make a bit of room for both of the caller and callee. And then we take the parameter, we pass on the parameter, and we call the wrapper function with the parameter from here. Again, this is something I can write down myself, or I can make, and sometimes it's actually pretty fun just to write these things down, but when I have unit tests. But if I don't have unit tests, I let my IDE to do this for me. Most often I let my IDE to do this for me, but sometimes it's actually fun just to do it by myself. So let's see how the IDE does this for me. So select the block of code. Because I'm using Mac, it's Command Option M for extract method. The people who use JetBrains products know that this is a JetBrains now. Extract method. I create it often, so depending where I want to have it. In this case, I want to have as close the scope as possible. Also because that shows another interesting thing for us later. And as I said, I give it a meaningful name. And there it is. I haven't coded at all. Just making a bit of a mess here. And the next one, what I do is I extract the parameter. Again, I choose a bit of code. Command Option P. I select this to the get something function. And there it is. Small steps, small changes, me not coding at all. The best thing, at least for me. But now this sort of looks for me is the get price is a bit on the wrong abstraction level, because we are in the routes, remember? But we are having something of a database connection close to it. I don't think this is something I like. So we want to move this get something outside of this function that handles all the REST API calls. And how to do that is we need to make get something an isolated function. Who knows what an isolated function is? Some people. So I'll just have a Venn diagram of all the functions. So with the set of all functions, there's a set of, like subset of testable functions. Like not all functions are testable, or at least easily testable. But there's a subset of testable functions. These ones that are easy to test that we can test. Easiest way for me to make testable function is to make it an isolated function, saying that every isolated function is a testable function. An isolated function is a function that gets all the information it needs as parameters. It doesn't reference to static variables, doesn't reference to global variables, and all that stuff. That's an isolated function. Every pure function is an isolated function. So with this one, we create this function that wraps the connection. We turn that into an isolated function. We can basically move that away of the route handling, and that makes this, again, a bit easier, fixing the mess a bit. What's the definition of a pure function? Thank you for the question. I love that. A pure function is a function that, with the same parameters, always returns the same value. So a pure function could be plus, like arithmetic plus. 2 plus 3 is 5. Pure function is something that you can memorize, that you can make, instead of a function, you can make a lookup table, which means that everything that grabs data from database is not pure function. So just an example. Thank you for asking this question. So yes, let's make this an isolated function, that we had the connection, because the connection, as I said in the beginning, that's something that's a sort of global variable, like outside of the scope of this function where we are. Again, I can do this by hand, but I trust my IDE. I select the connection, Command Option P, extract parameter. I set that to the target function, and then I have the function get something that gets all the data it needs to perform its like calculation as parameters. So this is an isolated function. If the connection would be something that always return the same value, then this would be a pure function. But because the connection.query, if connection query would always return the same, this would be a pure function. But because connection query is impure, this is impure. So this is the difference of these two function types. And then we sort of do the same with the other DB call. And for this, unfortunately, I don't have an animation, so use it just a very blunt transition. So we sort of do the same with the other one, like this. And now you start seeing how the code within the function of get prices starts to be more and more testable. At this point, I could even add unit tests. At this point, I would probably add like a single, quick, fast unit test. Yes, working with request response is very like annoying. Yes, I know how to do it. Then I would get like quick feedback loops for everything that I do from this point onwards. So this is what I would do. Now I've translated this function actually to be a testable function. But to actually continue with this, I want to get rid of the HTTP response handling from the domain code, because I don't want to have the domain code and HTTP handling to be in such a big mess. And yeah, also at this point, still what I see is there's another interesting concept here, is that still in the request handling, I do still see the connection. Again, still my HTTP layer needs to know about database connection, the concrete connection, or whether it's the shape of it doesn't really matter. So this is also something that we can get rid of. And how to do that is I start seeing shapes when I'm programming. And one of the how I think about code is that, and this is one of the biggest learnings for me when doing these practice, like code katas, code challenges, that if two pieces of code look almost the same, if I can turn them to be exactly the same, I can find some meaningful abstractions from the code. So that is like helps me a lot. So if I think about these two functions, how can I make them the same? Does anyone have any quick thoughts? How are they the same? They're both functions that takes 2 parameters. The other one just happens to be null, non-existent, void. In my mind. In the code, it just takes 1 parameter, but in my mind, it takes 2 parameters. It takes the connection, the database thing is, and it takes the other one is the domain sort of object or the domain concept in there. And then with that, I can turn a function to be a higher order function. Is there FP, functional programming people? Not many. So for who work with more object-oriented code, how you can read this code? What happens here is a function is a function that takes 1 parameter and returns a function that takes 1 parameter. From object-oriented perspective, whatever you see here is a constructor that returns a class, an instance of a class that has just 1 function. So this is the function of the class, and the first part is the constructor. This is how I sort of also read this at times. So let's do a bit of currying a function. So how this is done again. This is actually the only time I need to code. So this is the time when I need to type in the code so far. So far, I have not typed at all. Now what I do is I make a bit of room here, and I make a bit of room here. So I wrap the first function with a function, and then I just call the first function first. So I haven't changed anything, but this is the first time I'm actually writing code myself, and not just using refactorings. And then what we need to do is move the connection from this function that takes 2 parameters into the other function. So how we do it, again, sort of in our mind, we just make a bit of room, and then we move the connection to the first function. And then, of course, we call it in the get something. An interesting part of making curried functions like this is curried function can have names. This is important. Because now what we have is a function that returns a function. So there's like these two function calls at a time, and that can be a bit like, how do I read this? How do I read this? But now what I can do is I can give it a name. The get something turns to be get base price for. So now the function that I call the const price is just a function get base price for. Curried function can have names. So it looks even more like object-oriented, with the first get something be the constructor and the other one being just a function that has the name of get base price for. And with all these changes, what I have so far, I start seeing more shapes like this actually starts looking like repositories, a repository pattern, what I have here. And the route is getting cleaner, so the route doesn't know anything about connection anymore. I'm happy about that. The route only knows about the base price for and list holidays functions. It just knows that there's these 2 functions, I get them from somewhere, someone gives it to me, and then I can do the magic that I need to do. And the domain concepts that we're starting seeing like a bit of repository-like functions in there. And with these changes that we've done at this point is we actually changed the code from the left to be half of the code on the right. So like everything that is orange and green is still a mess, a bit of a mess, but everything that is blue has been, the dependency has been inverted and the arrows has been inverted to be more like hexagonal. And the next thing what we can do is we can separate the HTTP handling from domain logic, and it's sort of the same thing. So, and here is the trick, how I can make hard to test code easy to test code. Or in this case, annoying to test code into easy to test code. I move everything that handles about handling HTTP up and bottom and everything that is in the middle extracts something somewhere, and I have a function that is easy to test. So if I can move the hard-to-test codes up and down, whatever I have inside is easy to test code. That's a neat trick, and it's super simple. So if we get the code to look like this, we can just extract the domain logic into its own function, and then that makes the domain look also nicer. And here is just an example how it works in this example that I have. So we have a get price that now takes 5 parameters. And at this point, I'm still doing like the refactoring part. And again, like this is just me refactoring with IDE. So soon I will make more changes and start figuring out the namings and stuff even a bit more. So what we have at this point is a function. The original function, get prices, that we have an important abstraction which is taking stuff from the HTTP. It calls a function to a domain logic. So my route has a reference to domain logic thingy, something. It just calls the domain logic. And the domain, so route doesn't know anything about database or where the data comes from. But the domain logic, when I'm creating the domain logic handler, that has a reference to the thing on the database. Which sort of resembles a lot about this functional core imperative shell design pattern or hexagonal architecture. It's all the same. Same, but different. So what we did was, and this is pretty neat, so this far we can get without changing, like without writing much of code. Does it say that we did not? Yeah. Luckily, it doesn't say that we didn't need to write any code, because I needed to have the one parenthesis in there. So we start adding the test cases. Step 2, add test cases. Again, I haven't read the code. I just know it's a lift pass pricing, so it's about like ski lifts. I get a ski lift. So what I do is I start thinking about like concepts. So now I know there's holidays, because there's list holiday functions. There's a base price thing. So these are these 2 functions that need to be given. So I'm giving just the context of, let's not think about holidays. And I run my first test case. I get a base price of 20. I choose a day, like someone whose age of 20 probably goes skiing a lot, I guess. This is from France, so that probably means a day. I don't know, I don't speak French. I choose a date. I expect the result to equal the base price. I run my test case, and I see that it fails. I'm like, what's next? Is there something wrong with my test case? No, it's not. This is characterization tests, so the idea here is I give inputs, and whatever is the actual result, cost 13, I use that as the expected result. This is a way for us to take any existing code base, run test cases to see what it actually does. So I make it a test case that says on Mondays there is a 35% discount. I go to the next test case. I'll just use a Monday for a kit. And I learned that kit on Monday is more expensive than an adult. Didn't see this when looking at the code myself. I add one test case at a time, looking at also the coverage and trying to cover test cases that where I want to go. And I try to give test cases sort of meaningful names that describes the context, that describes what it sort of happens in there. And when I'm happy with my test cases and the coverage looks pretty okay, I can go to the next step. Of course, test coverage doesn't tell everything, because there's mutation of in certain mutation permutations, I might actually still have uncovered examples in there. So it's not as easy as just look at the coverage. But we see here there's like 2 pieces of code. There's 2 branches that we never get to. One of them actually shows that the refactoring we did change the behavior. I'm honest with you now with this. The other one is just dead code. Again, something we didn't see. It's code that we never get to. But that's the second step. So it's the focusing on the readability of the test cases, using characterization tests to figure out what is the actual behavior. And the idea here is the test cases, even if there would be a bug, like probably there is a bug that a kid out of like on Monday is more expensive than an adult. I would guess that is a domain error in there. Even though that is there, I'm not fixing it, I'm not doing anything that, I'm just sort of locking the behavior. Some people talk about these locking tests exactly for that reason. So then we go into the fun part. Actually, everything so far is fun, but I mean, like refactoring is also a lot of fun. The code that we see on the right looks pretty much the same that we saw earlier and previously. The shape has not changed much, if at all. And when we do these exercises, and I did this exercise with my friends on a conference once, and how people typically start this is like extracting small things. How do I do this? And figuring out like, what are the smallest things that I can extract methods into? I start exactly the same way. I start like, I want to change the whole thing. And I use the ship of Theseus or stranglefish pattern for that. Does anyone know what the ship of Theseus is? Quite a few knows. So that's a thought experiment for the others, for the rest. Thought experiment that if you take an old ship, a wooden ship, if you change every single wooden part over the course of time, is that the same ship anymore? That's like this thought experiment of ship of Theseus. Taking that into code, I make still a bit more mess of this. So I start writing an if clause to get something. And I take like one tiny sort of vertical slice that if the inputs are like this, then I go to this new path. If the input is not like what I'm wanting, it goes to the old code, the code that provides value, what someone might call legacy code. So, and this what I do is my favorite way of programming is programming by wishful thinking, so I start writing the code that I would wish to see. If I'd been doing this with my friends in production code, this would be the most important time of everything. So none of the code exists. We would write 2, 3, 4 different ways of how we would want to read the code when we come to this in 2 weeks or 2 months. But this is just like an example what I did. None of this existed, this code, that's why there's all the squigglies. And then I start implementing this part. And the first one is just for all the kids, it's always, in any situation, it's always free for kids under 6. I check the coverage results. I see that there's more branches now that are not covered. What I do is I go and I delete that code. How I do that is I go and make the if statement to be false. I run my test cases. Everything is green. And by the way, at this point, the test cases take a split second to run all these test cases, so it's not long. I see that this is still green, and then I just simplify the statement, and that's it. I take the next small example that in this case would be like adding lift pass type, just to get a bit more complexity into these places that I'm doing. Lift pass type, I'm running the coverage results, and I'm deleting the code. Guess what's next? I take another slice and another slice, and I always delete the old code. And then at the end, I'm in a situation where none of the old code exists anymore. This is actually magic. So I was doing this I was doing this with a code base. So I was writing a code for no-code platform, the runtime of that. And we needed to do something like this, but the code base was huge, big. I did that together with a colleague who was on her first job ever. We made the first vertical slice. And after that, she could so we paired on that. After that, every single day, she could just push a new one into master and into production, and we never break the production. So learning to do these, like tiny slices, is magic, because we don't need to break the software when we're doing it like this. And then in the end, we just remove the if statement. So this is sort of what the get price, the domain logic looks like. You remember originally it was like, is it better? Honestly, I don't know. Depends what we're used to. And with this sort of the phase, what I want to say is it better? It always depends on the context. And in this case, what we can do is we can write 2, 3 different ways of how we could actually want to read this. And as I said earlier, if I do this with my colleagues, I would do this phase earlier. This would be the first thing to do, like figuring out how do I want to read this when I come back to this. Changing from the first one to the second is easy. Changing from the first one to the third one is easy. We have test cases and all this ready for us, just for us to sort of give an idea that what we can do. Because, and this is my good friend Eka gave an example, that when they managed to write test cases, very meaningful test cases, they could give the test case to their CTO. They gave it to the CTO. CTO read it and said, right, that's a bug. Imagine that someone of a C level can read your code and say, good, oh, that's a bug. There's so much value in that. So to summarize, transforming hard to test code to easy to test code, please use your IDEs. I trust my IDE to do these things. There is these 2 tricks. One is that moving the hard to test code up and down and extract everything in the middle. Very easy trick to make it testable. Focus on test readability. Use characterization tests to understand what is happening. It's actually very nice and easy. And then refactor outside in these cases, and using the ship of Theseus, because ship of Theseus pattern is so magic when we see that in production. That's it. I love T-Turtle.